Question number 7, we're going to either take the absolute value of the outputs or the absolute value of the inputs and graph them. So the first one is, if g of x is the absolute value of f of x, what this statement is saying is we are going to go and we're going to take the absolute value of all of the outputs. So none of the outputs, if you take the absolute value of all of your outputs, no outputs can be negative. But here's the part of the graph where f of x was negative. It can't be negative. It's going to turn all the negatives into positives. And all the negatives on this side of our graph, from about -5 on, those negatives have to get turned into positive. So think about taking your outputs, your y values, and making sure that they end up positive. If that happens, what we're going to do is we're going to end up reflecting the graph across the line, y equals x, or basically our x-axis. So this point down here is a biggie to get flipped. That is about a -1.1. I'm just going to try to take this. I'm going to flip it so that it comes down to about a -7.5. So now it's going to be up to a +7.5. That point, just trying to go straight up to 7.5. We're going to leave zeros as zeros, but all of this gets flipped up above the x-axis. So now it's up there. So I'm going to take that last 2 marks off. I don't want that blue. So the green is going to get flipped. Oh, give me a blue. It's going to get flipped back up here. The other part of the graph that's going to get flipped is this side over here by the -5. Anything from here on to the left is negative. It's going to get flipped upward, and it's going to come up here. So my final graph is going to be the blue graph I'm going to highlight. All the negative outputs get flipped as positive outputs. All the positive outputs stay exactly the same because you take the absolute value of positive, it stays positive. So this is the basic shape of our graph. We got a little anomaly there, but there it is. In the second graph, what they ask us to do is find the absolute value of the inputs first and then graph them. So whenever this happens, what we're going to do is, no matter what our input is, we're going to take the absolute value of it. So if we put in a positive one, the absolute value of a positive one is a positive one, and it gives us a value somewhere in here. If we put in a 2, it gives us an output here. We're only taking the absolute values of the input, so it's not going to have any impact at all on the right side of the graph when our inputs are already positive. Where this absolute value of your inputs comes into place is when you're on the left side of the y-axis. So now when I put in a -1, the first thing it does is going to take the absolute value of a -1 that's going to turn into a +1, and that becomes the input. When 1 was the input, we had an output of about a -7.5. So that value of a -1 returns a value of about a -7.5. If I put in a -2, same thing occurs, put in a -2. The absolute value of a -2 is a +2. Then we put the +2 into the function that we have here, and the +2 return the value of about a -2.5. So at a -2.5, I should get another -2.5. So trying to make sure I got that somewhat close. So really what we're going to do is we're going to end up copying the entire graph. This side of the graph, which was the positive inputs, gets copied over here for the negative inputs. So the negative x, which you take the absolute value, turns it into a positive x. So all of these things here as positive x's will reflect the same values that you had for your graph on the right side. So the graph that I'm talking about then is this blue graph is going to get transferred in carbon copies kind of language we had. So this point of 2.5, 0, somewhere in there, should be copied to the other side. So the entire graph of the absolute value of the inputs, the original right side stays the same, the right side of the y-axis. Then we reflect it across the y-axis to get the rest of our graph. So this red graph is, or the W shape, the graph of the absolute value of x first. So it's the difference of graphing the absolute value of your outputs versus your inputs. If it's in the first graph, you're taking the absolute value of your outputs. No outputs can be negative. Reflect them upward. If it's the absolute value of your inputs, all of your negative inputs get turned into the positive inputs immediately, which then means all of these positive outputs will be duplicated over here with your negative inputs. So it's a reflection across the y-axis. 2 different types of reflections with absolute values.